Hello everyone, welcome to my video tutorial about ER diagram. In this tutorial, I am going to explain how we can use the concept of aggregation in the ER diagram. The concept of aggregation is used to present information at the abstract level, and it allows us to build composite objects from its component objects. I am going to explain these using both simple as well as complex scenarios. So to start with, let us consider an example of ER schema which stores information about loan applications submitted by customers to different banks. This ER diagram represents the fact that customer applies for a loan to a bank. It has two entity types, bank and customer, which participates in the relationship type loan application. To see how the concept of aggregation is applied in this ER diagram, let us consider an entity type bank, which has two attributes, bank name and bank address. So we can say that an entity type bank is an aggregation of its attributes, bank name and bank address. Similarly, we can say that an entity type customer is an aggregation of its attributes SSN, customer name, customer phone, and customer address. This is a simple scenario explaining how the concept of aggregation can be applied in the ER diagram. To see how this concept can be applied into more complex scenario, let us consider the fact that loan application results into loan approval. To represent this fact in the ER diagram, I am going to add one more entity type called loan approval. As you can see in this ER diagram, here the binary relationship loan application is now converted into ternary relationship to connect three entity types, bank, customer, and loan approved. This ER diagram assumes that every loan application submitted by customer results into loan approval. However, in real life, some of the loan application also can get rejected. Hence, this ER diagram is not correct. So, to represent the fact that some of the loan application results into loan approval, I am going to add one more relationship into this ER diagram called result seen. As you can see in this ER diagram, the relationship type result seen is connected to entity type loan approval. More interesting fact to notice here is that two relationship types, loan application and result seen, are connected with each other. This type of representation is called relationships among relationships. However, ER model does not allow this type of representation, and hence we cannot use this in ER diagram. So the alternate solution is to combine entity types bank, customer, and relationship type loan application into a higher level aggregation class and relate this class to an entity type loan approval, as you can see in this ER diagram. However, ER model does not allow this type of representation. But it is important to note that there are some semantic models that do allow this type of representation. So, to represent this complex situation in the ER diagram, we are now going to create a weak entity type called loan application and relate this weak entity type to an entity type loan approval, as you can see in this ER diagram. Here, entity type bank and customer becomes the owner entity type for the weak entity type loan application. So this concludes that we can represent any complex situation in the ER diagram by introducing additional entity types. That is all for now. I hope you find the information in this video helpful. See you in the next video. Till then, goodbye.